Hello friends, welcome back to our channel. This is part 3 of video series where we are going to discuss CAM in detail. Already in part 1 we discussed what is the difference between CAM, RAM and TCAM, and in part 2 we discussed the complete pinout of CAM memory. And in this particular video, that is part 3, we are going to discuss how can we implement a CAM. So basically the digital logic of a CAM memory. Friends, if you have any idea how we can implement CAM or you already have some information, please share your idea in the comment section so that we can start a discussion there. Otherwise, I am going to reveal one of the implementation of CAM. And now without wasting much time, let us get started. Friends, before digging into the implementation, so I have a question for you. What do you think, what will be the CAM's output latency? And as we know that it gives the match address at its output, what will be the latency between when we give the data at its input and when we will get address at its output? How many cycles does CAM take to give match address at its output when data is applied at its input? And just for your information, the typical value that CAM takes is 1 cycle. Very surprising, right? Very less. But it is true. Now we'll see how to implement CAM memory in digital design. Friends, there can be various ways to implement CAM memory. So whatever way I am going to tell you, it is one of the way. So the way I am going to tell you, it needs a RAM memory, or in FPGA terms we need a BRAM, that is block RAM. Now let us see how to implement a CAM memory using a RAM memory. And the RAM memory behavior is well known to everyone in the digital community. So we are not going to discuss it here. Friends, the way I am going to propose to implement CAM using RAM, we need this type of grid. And in this example, I am going to implement a CAM which is 8 into 2. 8 into 2 means it will have 8 locations and each location can store 2 bits. So that means data bus will be 2 bits. And output, because it has 8 locations, so address will be 3 bits. So match address will be 3 bits. These flags are always 1 bit, irrespective of the size of the address line and data line. So now let us discuss how to prepare this grid. So on the left hand side I have written CAM data, and on the top I am writing CAM address. So as we know that this CAM has 8 locations. So let us give the address 0, 1, 2, 3, 4, 5, 6, 7. So these are the addresses of a CAM memory. All the addresses we need to write it here. This is a CAM data. It has 4 possibilities: 0, 0, 0, 1, 1, 0, 1, 1, 1. Now we need to see where this 0, 0 is written inside the CAM address. Let us say here I am writing 1. That means 0, 0 is written at address 1 of CAM. 0, 1 it is written at address 5 of CAM memory. 1, 0 is written at address 3 of CAM memory. 1, 1 is written at address 0 of CAM memory. Friends, it is quite possible that any of the data is not written at any of the location. For example, let us assume that 0, 1 is not written in any of the location. For that case, all the bits corresponding to this data will be all 0. That means 0, 1 is not written anywhere. But in our case, we are writing it at address 5. Other observation, this 6 and 7 column, right, the address 6 and 7, nothing is written at that address. Even address 4 we have not written anything, address 2 we have not written anything. So in a nutshell, some of the CAM locations are empty, and it is possible that any of the data combination is not written at all in the CAM memory. Now just assume that if I implement this grid in a RAM memory, that means the first location of RAM will store this data. Second location will store this data. Third location will store this data. And fourth location will store this data. And output of RAM memory, that is RAM data, will be 8 bits. Now how to access each location of a RAM? We need address lines. How many address lines? 2 address lines. If I select 0, 0, it will select this location. If I select 0, 1, it will select this location, and so on. Now friends, we are very close to the CAM implementation. At RAM address 10, we will apply cam data 10. So this data we want to search in the cam memory. And according to this cam data, it will select one of the location. For example, if we select 10, then what will be the output of this memory? It will be 00001 zeros. That means it will say that this is the match address. So this match address will appear at the output of the RAM memory. And what does it indicate? It indicates that this data 10 is written at the third location of CAM memory. But friend, there is a slight problem. And the problem is the output of CAM memory, the match address, is only 3 bits. Here we are getting the match address as 8 bits. But these 8 bits are enough to tell us that 10 is written at third address. Now to make it compatible with this CAM, we need a match logic here. This match logic will tell you the match address, which will be similar to the CAM output. Apart from this, you will have a match flag, single match flag, multiple match flag, output of this match logic. Now if any of the bit inside the match address is 1, match flag will be asserted. That is easy to implement. Now if only one of the bit is high, then single match flag will be asserted. That is also easy to implement. Now if multiple bits in a match address are asserted, then multiple match flag will be asserted. That is also easy to implement. Friends, similarly, the same match logic is responsible to convert the output of RAM, that is match address of 8 bits, to match address of 3 bits. So just for your information, because here the address is 3, so the value of match address will be 011. Friends, now I have a question for you, very interesting question for you. And the question is related to match logic. Match logic has 4 outputs: match address, match, single match flag, multiple match flag. And it has one input, match address, which is of 8 bits. So this match logic consists of basically 4 logics. One which calculates match address to match address, another one which calculates match flag, another one which calculates single match, and the last one calculates multiple match. Friends, in the question you have to tell me all the 4 logics. You can straightforward tell me the digital logic, or you can write the Verilog or system Verilog codes for all the 4 logics. Here you can pause my video for some time. Try to think of its answer. If something comes to your mind, please write it down in the comment section so that we can start a discussion there. Just take it like a test for you. Whatever we have discussed in our technical bytes so far, apply all those formulas and tell me the answer. I am expecting this answer from all of you. So for the time being, I am going to quit this session here only, so that in the upcoming video, the first thing that we will discuss will be match logic only. I hope that this video will be informative and interesting for all of you. If you also like this video, please press the like button and you can share your feedback as well. And in future also we are going to create many such videos. So to be aligned with our channel, don't forget to subscribe it and press the bell icon to get the notification of all the upcoming videos. Thank you so much for watching and your time.